Look at this return. The signature matches the profile exactly. That's it, we found it.
All right, crane operator, bring it down slowly. We are approaching the water line. 5 more meters.
Bridge, this is engineering. We are maintaining course despite the heavy swells. Engine output is stable.
We follow the primary conduit line to the connection point.
And the secondary
Excluded,
valve.
excluded.
Understood.
Ready to dive.
Safety checks are complete. All green. You are clear to proceed with the dive.
Depth at 4,000 feet, pressure holding steady. Maintain current vector, Charlie.
Roger that. Mission control. Steady descent.
ROV-1, adjust your pitch by 5 degrees south. We need a closer look at that thermal vent. Confirm stability before engaging the drill.
There's definite thermal overrun here on the turbine, likely exacerbated by the fuselage crack.
Maintain heading 045.
Roger that, 045. Approaching target depth.
Copy, steady as she goes.
Acknowledged. Initiating brush sequence on Sector 4. Documenting successful sediment clearing.
Very clean. This will significantly reduce the maintenance time.
The critical path clearly shows we need to secure the east quadrant by 1800 hours.
And the weather contingency?
That's factored into the resource allocation here.
As you can see here, the concrete spalling on the main support beam is extensive. The rebar is exposed and severely corroded.
The primary challenge here is the load distribution during the initial ascent. If we don't compensate for the torque on the starboard side, we risk structural failure.
The maximum load is 400 tons. Wind shear is acceptable at 15 knots. Margin is tight, but within tolerance.
See this section here? The hydrodynamic stress at this point is too high.
But the structural integrity holds according to the simulation.
Only if we use the reinforced composite.
All right, slowly lower the cradle now. Watch the alignment on the east side.
Roger that, lowering slowly.
Depth reading 1,050 meters, steady descent, 1,060, 1,070, speed holding constant, navigating clear of the western ridge, 1,080 meters.
Adjust trajectory by 0.05 degrees. Steady now, watch the starboard clearance. Okay, cradle is secure, maneuver complete. Diver 1, confirm pressure readings on the manifold. ROV, engage the latch mechanism on section B, move slowly to avoid cable entanglement. We have a red flag anomaly at grid reference C5. Surface, hold position. Underwater team, acknowledge and investigate.
Roger that, proceeding to C5.
Confirm strap tension on line 3.
Ensure the shackles are double locked before proceeding.
Clear the zone.
We are initiating the main lift sequence now.
Control, this is Alpha. We are proceeding with the lift. All teams report status.
Bravo, green.
Charlie, holding pattern steady.
Altitude steady at 5,000. The aircraft is continuing to rise. All systems green.
Altitude achieved. We are green across the board.
We did it! The recovery is complete!
Yes, we finally did it.
I want those pumps running at maximum capacity right now. The stabilization priority is the east wall.
Keep coming straight back slowly, a little more to the left. Okay, hold position. We are clear for connection. Slow down near the access panel on the lower section. I need a closer look at the rivets. Copy that, easing the throttle now.
Confirm, we will adjust the berthing schedule for the tanker. Stand by for updated ETA.
Roger that, engineer. Proceed.
Thank you, Harbor Master.
Easy now, easy. And stop. Good job.
The successful docking of the Excalibur marks a new era in deep space recovery.
Hold it there, bring it down slowly on the starboard side. Watch the clearance.
Copy that, moving slowly down.
Perfect, lock it in. Okay, hold it right there. Looks good.
The scope involves extensive work on the upper fuselage. We need to prioritize safety on the scaffolding while we assess the wiring harnesses.
We need to ensure Phase 2 mobilization is complete by the 15th.
What about the permitting approval right here?
We already accounted for that in the critical path analysis.
The biggest challenge is stabilizing the foundation without compromising the historical elements. We need precision here.
Move that segment slightly to the right there. Secure it at the connection point on the fuselage.
As indicated in the schematic, the rust penetration exceeds tolerance levels. I'm documenting this as a critical failure point.
This joint here, the shear load is critical. We need to reinforce it.
I agree, but look at this alternative route for the rebar.
That could work, provided we maintain the depth here.
We must address this load-bearing wall. The damage here and here indicates imminent failure.
Phase 2 is proceeding on schedule. Crane operator, lift stabilized?
Good.
Bring it down slowly. We need to clear the bay for the next section.
Reading confirmed on line 3. Pressure holding steady. Note the discoloration near the exhaust port.
Okay, lift confirmed. Bring it up slowly now. And traverse east. Easy, easy, lower to the mark.
The corrosion on the strut is extensive, particularly near the hydraulic lines. Pitting depth appears significant.
Measurement confirmed. The turbine blade spacing is nominal 0.05.
Zoom in on sector Gamma 4. We need a closer look at that trailing edge.
Affirmative. Adjusting magnification now.
Monitor the crane movement closely. Sarah, ensure the fabrication team adheres to the new specifications on the tablet immediately.
Check the specifications on the tablet, then proceed with lowering the rack into bath 3. The timing is critical.
Perfect run, guys. The thrust is exactly where we need it.
Confirmed. All systems green.
We need to ensure the alignment is perfect before securing the coupling.
Acknowledged, Doctor. We're proceeding with the lift now.
We need to install the bracket first, then the sensor array.
Does that include the wiring harness?
Yes, simultaneously.
Easy now. Hold it steady at the pylon. We are clear for final alignment.
Hold it there, micro adjustment on the starboard side. Check alignment sequence. Okay, bring it in slow. Apply the adhesive evenly around the edges, then we'll use the laser alignment for placement.
Roger that. Ready for application.
Are sections 4 and 5 complete?
Yes, engineer. Moving to 6 now.
Excellent. Maintain the pace.
Maintain current velocity, tug 1. We are entering the paint bay. Clearance looks good on all sides.
Cleanliness is critical for adhesion.
The color match is perfect. Maintain the 3mm spray distance and ensure even coverage across the fuselage. Make sure the alignment matches the schematic exactly. That's perfect. The positioning is verified.
All right, team, this section looks good. All quality gates are passed. Let's move to the north elevation.
Landing gear installation is complete, systems integrated and fully nominal.
Good. Log it and prepare for retraction test.
Nose gear steering check complete. All parameters are nominal.
Ensure the torque is exactly 1/5. Sequence the lugs properly. Safety first.
This pilot interface is critical. Double-check the connections on the primary flight display before finalizing the install.
Control to Bay 3, confirm alignment.
Alignment conformed, engineer.
Roger that. Initiating final sequence in 3. Alignment confirmed. Clear to seal.
Copy that. Initiating seal sequence. Initializing systems diagnostic. Power fluctuation detected. Parameters stabilizing. Check complete.
Ground test successful. We are cleared for flight.
Final checks confirmed, flight clearance given.
Engines are spooling up. We are at T-minus 10 seconds.
Roger that. We have ignition and full thrust.
Telemetry is stable. Confirming go for orbital insertion in 30 seconds.
Brake set, Captain. Pushback complete.
Roger, confirmed. Thanks.
Aileron roll initiated. Rate of turn is consistent with projected metrics. No significant yaw deviation observed during climb.
We are approaching Mach Q.
I need status checks from all stations. Report any anomalies immediately. Wind shear advisory active. Maintain approach speed.
Roger, tower. Speed checked.
Landing 3 green.
Confirmed touchdown. The first flight is a complete success.
Welcome back. The telemetry data streamed perfectly throughout the descent.
Excellent. It felt stable up there. Let's review the figures. The aerodynamic stress points peaked here at Mach 2.2.
Right, the vibration feedback was significant during that phase. We need to review the structural integrity data.
It's signed. We are clear for the flight test.
Confirming all systems green. The aircraft is cleared for handover and delivery flight.
The structural integrity was our biggest challenge, but we kept 90% of the original fuselage.
Remarkable work, Doctor. On behalf of the command, thank you.
The complexity of the wing spar replacement was significant, but our team managed to reduce the weight while increasing the overall strength, as you can see here.
बालू के चीफ धारित्री नदी माली भूलता है गेटी वाणी जेग भंती अली देशन ईशनेर भक्का बाने केसे
By analyzing these data points, we can apply the lessons learned directly to the upcoming recovery operation.
This valve assembly is the critical failure point. Does everyone see how the schematic correlates to the physical hardware?
Remember, engineering is not just about calculations. It is about imagining the future and having the courage to build it.
All right, team, easy now. Lower the payload onto the center of the flatbed. Confirm securing the straps once it's set.
As you can see on the schematic, the support structure must be prioritized and the timeline for the recovery phase.
If we follow this schematic, the stress point is evident here. However, the data suggests an alternative approach for long-term stability.
Children. And so, the successful restoration of the X-51 demonstrates what is possible when we push the boundaries.
Thank you all so much. I am truly humbled by this recognition. I share this award with my incredible team.
The legacy of this aircraft is now permanently documented, a testament to the hard work of the entire restoration team.
Please. This turbine blade uses a single crystal alloy, allowing it to withstand extreme temperatures. This is the future. You have a real knack for this, and I'm confident you can lead the next phase.
I appreciate that. I'm ready for the challenge. The alignment is complete.
The stress test results look good on the holo display.
We are ready for phase 2.